And I've got the slides, and I'll be kind of driving. So it'll be a matter of me remembering Google and sharing screens. I think I want to share. Let's see, that one, I think. Actually, no, I'm going to share this screen, I believe. I'm going to share that screen, and I think if I hit my slideshow. All right, did that come up in the correct location?
Yep, that looks perfect.
All right. Again, with 3 screens and Google being weird with sharing screens, I want to make sure I'm all in the right location. But yeah, so I'll turn it over to Nathaniel, because he's really the one who kind of organized this and is going to be doing the kickoff first couple of slides. So I'll turn it over to Nathaniel to get us started.
Thanks, John. Yeah, I get to do the introduction, but John is really the SME here that you want to hear from. But I just want to start off by thanking Justin and the rest of the GIS Association for the opportunity to present today. Before we dive in, talking about CCAP here, which I'm sure everybody is grateful for, one more acronym that you've got to learn what it means in this industry. Just want to give a brief introduction here. If we haven't met yet, my name is Nathaniel Litter, and I serve as a senior project manager out of Dewberry's Huntsville office. I've been based in North Alabama now for roughly a dozen years. And if you aren't familiar with Dewberry, we're a large architectural, engineering, and construction firm headquartered in Fairfax, Virginia. We were founded in 1956 and have grown to 60 locations nationwide with more than 2,500 employees. That includes our 3 Alabama offices strategically located in the north, central, and southern parts of the state. And what sets us apart from many of the other large businesses in our space is that we remain a family-owned business, which means we don't have the pressure of delivering results to investors or outside stakeholders, but keeps us squarely focused on our clients. Next slide. So yeah, like most businesses, we offer a diverse set of services covering a variety of markets. Specific to our talk today, we're going to focus on our geospatial technology services. And this is the business unit which both myself and John, I see we've got Al on the call, we all fall into this business unit. So our group comprises approximately 150 geospatial professionals across the country. But we're supported, I said we've got those 60 offices. So locally, we're supported by many survey staff and other geospatial experts across the organization, which is why on the slide you see closer to 450 geospatial professionals. All our services listed above, this is a brief snapshot of our capabilities. So we're an award-winning Esri Gold partner, as well as a Microsoft partner. So we specialize in utilizing commercial off-the-shelf software to develop applications and implement low-code, no-code solutions to provide meaningful insights and visualizations to our customers' data. So while we're probably best known in the geospatial world for literally writing the book on LiDAR, as well as serving as a Gypsy Prime contractor since the program's inception. FEMA's actually, as a company, is our largest client. So whether we're performing data collection in the field or utilizing real-time stream from FEMA, we deliver time-critical analytics and decision points related to a variety of natural disasters and supply chain management issues. Additionally, like most companies that have presented on here, we own and operate a fleet of the latest and greatest sensors for collecting LiDAR, bathymetric LiDAR, as well as aerial imagery data to support our clients. So with that, I'm going to throw it back to John, and he can tackle the meat of why we're here today.
Sure. Thanks a lot. Thanks for the introduction. Like I said, I've kind of introduced myself a little bit. like I said, I was only been with Dewberry for a little over a year now, but prior to being here, Dewberry as a project manager, I spent the previous 20 years or so with the NOAA Office for Coastal Management over in Charleston, South Carolina, where I helped lead up and develop some of these products we'll be talking about today, which is the NOAA Coastal Change Analysis Program, aka CCAP, another acronym for you that Nathaniel was talking about. And so I'm pretty much going to kind of talk through kind of what CCAP is, kind of, you know, where it's derived from and how it's created, but then also, you know, what specifically we're doing down in the coastal region as well, and also get into a little bit about, you know, how we're developing it, where we're developing it, but why we're developing it, and what it can be used for. So usually when I give this type of presentation in an audience, in a live audience, I like to ask the group, you know, who's heard of CCAP data, and you know, a couple hands go up, but then I'll also ask who's familiar with or have used the USGS's NLCD, or the National Land Cover Database, and typically get a lot more hands up. But if you're familiar with NLCD, then you're familiar with CCAP. Essentially, CCAP data has been for many years, for over a couple decades now. They produced the coastal land cover data in at the 30-meter scale, at the national scale, and that fed into the National Land Cover Database, or the USGS NLCD product. A little bit of the difference with the CCAP data is, you know, we're producing it every five. They were producing it. I say we because that's what I did for 20 plus years, but CCAP and NOAA produces it, you know, every 5 years, repeat cycle, going back to 1996 up to 2021 in the CONUS wide area. You're kind of seeing the outline in blue is where they produce the data. Some regions actually go farther back in time as well. These data are available online through a viewer, but it's a 30-meter product. And for the longest time, you know, 30-meter product was fine. It was meant to be a national product, something that's, you know, revisited every 5 years. It's a monitoring type of product, not really made for working in people's backyards down to the county level. Really small, fine detail. It wasn't really made for that. That was the original mindset of CCAP. You know, 30-meter was fine, and it did work for the majority of what we were doing. You know, along the same time, for the past 10 years or so, NOAA has been producing a high resolution land cover product line kind of alongside of it, but that was always in smaller project based areas, something like, you know, the Pacific Island territories and the Caribbean Island territories, smaller, more manageable areas. It's really, you know, just processing at a 1 meter level at that scale, you know, 10, 15 years ago was really difficult to do in terms of cost, in terms of processing, you know, the algorithms and the AI and the deep learning. The methods really just didn't exist to doing it at that time. But NOAA has always had a vision to produce these data better, faster, cheaper. You know, better doesn't mean the absolute best. Faster doesn't mean you're going to get it next week. Cheaper doesn't mean it's going to be free. But it is going to be better, faster, and cheaper than it always used to be at this 1 meter or high resolution scale. And they have worked on that for a long time. We were involved with a lot of pilot projects with different companies trying to develop these works. And then a few years back, through some very large federal grants, you know, the bipartisan infrastructure law, Great Lakes Restoration Initiative, there were a lot of money came through NOAA and was dedicated to the CCAP program to help fulfill this vision of a 1 meter product. It started off with a 1 meter national build out based on, you know, 2020, 2021 imagery. We use NAPE imagery for this because it is a free data set, again, driving costs down. And during this initial first phase, this 1 meter product, it wasn't focusing on the full the full CCAP scheme, but it was focused on a limited number of classes. So impervious surface, a canopy layer, which had forest and shrub, and also a water layer. And the goal being start off with this initial product, get something out there nationwide to show it can be done, and then work through subsequent funding cycles, working with projects, different projects and partners and money sources to flush out those additional land cover classes. So as I said, it is available right now. That first phase product, that phase one with those 4 classes, is available everywhere, what you see in the dark blue areas. Those are where it is available, and that's kind of what we're working on now. But something that to make note of this graphic that we like to show is anything in the light blue, so those interior portions of those coastal states. NOAA was able to work with Ecopia. That was the partner that produced these first rounds of data. They were able to work with Ecopia to essentially get bulk funding, bulk prices. So for these coastal states, if they wanted to pick up those 4 class products at a 1 meter scale, they could get in on the cheaper pricing for the interior portions of their state through this NOAA contract. And this first product, again, it's a 4 class product developed by Ecopia, and it is, well, it's a good product. There are some issues with it. I'll just kind of show you right here. These are the initial products that are available now. So you'll see across the bottom, you have the impervious surface product. In the middle, you have a canopy, which is a forest and a shrub layer. And then on the right, you'll have a water product. These three data layers are available for download nationwide in the coastal regions. And there are a few areas now that do have the full CCAP scheme, the full 20 class scheme that is available. Examples are the Tampa, Florida region, Houston, Texas, I think 11 or 12 counties around that, the Houston Galveston Council. The full state of Maine is available now. And the reason these were done was because different groups came to NOAA, seeing that the base data was there, and they came to and approach NOAA, or NOAA worked with them to say, hey, we've got some money, let's put it in a contract, and let's develop the rest of these land cover classes for those target areas. So it's kind of a win-win situation that NOAA gets the additional data produced for a CCAP product, and then the funding organizations get land cover for their area. Again, it's not a whole lot of areas have it done yet, but it just so happens that we are working in this region that you're seeing on the screen now. It's 8 counties along the Gulf Coast. There's 6 counties over there in Mississippi, but then also the first 2 counties over there in Alabama are within this project area that I'm going to be talking a little bit more about coming up here. So the class scheme, again, what's available now at a base product is those, the impervious, the canopy layers, and the water layers. What you see on the left are really kind of like more of the upland and the land use classes, the cultivated pasture, grass, forest, scrub. And then over on the right, one thing that kind of makes CCAP really specializes in and does a lot of effort in is creating some wetland classes. So a little more value added as opposed to what you might get from the USGS. The CCAP product line does separate salt from fresh, the estrin and palustrin, and then it also has forest, scrub, emergent, and aquatic bed classes. And there also is an unconsolidated shore class, which are kind of the mud flats and the tidal flats as well. So that's the class scheme. Just showing you kind of what we're doing now. Again, we're working right now on that phase 2 product. That's that full CCAP class scheme. The way it's being done, really, we're taking them on in chunks, in phases, the way we're working through it. And we are taking a kitchen sink kind of approach to this land cover mapping. It's very easy to go out there right now, and there's lots of companies and organizations and algorithms out there pitching the one size fits all. We can feed in the data, we can use our AI, deep learning, and you get a great result at the end. Through many, many years of experience and looking at the results of those products, they do some great stuff, but they're not the be all end product. So we have really found that you really need to take a varied approach as to how you're classifying these land cover products. We take advantage of all ancillary data we can get our hands on, ranging from LiDAR data, existing national wetlands inventory, soils, parcels and zoning, open street maps, just other ancillary geodata sets. The way we're classifying them, we're relying heavily on object-based image analysis and expert rule systems to do a lot of this work. We are leveraging machine learning algorithms within the object-based world. We are also doing some of the old-fashioned cluster busting and bringing that in where needed to help tweak and clean up some land cover classes, as well as custom geospatial models. And one thing that we avoid as much as possible, but ultimately has to be done, is hand editing. Again, all these models, all models are useful, but they're all wrong in some way, shape, or form. So we know there's issues in the output products, so that's where we go into the hand editing phase. And all along this whole product cycle, we're doing feedback loops and quality control along the way. As I said, what you see in the top left, that's an initial product. That's something that you get right now. It has the very simplified classes. In the middle is the NAPE imagery. And then we're working towards what you see on the right, which is the final land cover class at a 1 meter with, again, up to upwards of 20 land cover classes, depending on where you are and what might be available. And we're taking that kitchen sink approach, is where we do whatever fits best and whatever works to classify what we need. As I mentioned, we're doing it through a phased type approach. So, in phase 1, we have those first classes that are available, that impervious surface, water, and canopy, and we're cleaning up those products. Again, this phase 1 product that's already available was a purely AI-driven land cover classification, and it has issues in it. So our first product is, we're cleaning that up in phase 1. In phase 2, we then are adding in those land use categories, which are, that's where we get the open space developed, which are like your managed grasses. You've got the natural grassland, you've got cultivated and pasture and bare, and all those classes are being modeled in and added into the class during phase 2. At the end of phase 2, we do have a wall-to-wall land cover product. So when we move into phase 3, we start bringing in the wetland categories. Again, we've done a lot of modeling at this phase. This is where we're really bringing in a lot more of the topographic characteristics. We bring in more soils characteristics. We rely on national wetlands inventory for training type locations during all our models. And so at this phase, we have a land cover phase. If we bring in a water or a wetland kind of layer to lay on top of it, and that gives us our wetland classes. And then phase 4 is really just a final wrap up. That's where we put that bow on the package at the end. And one thing that's really kind of important to note along this whole approach is, we're developing this through a contract with the NOAA Office for Coastal Management. NOAA is really our customer in this case, even though the money is coming from an outside source. So when we deliver each of these phases, we're just sending them to NOAA. They have a chance to review the products, and they give us feedback on each layer as we're going through this. And so each phase, there's an iterative process where we get quality control, and we have feedback loops built into each phase going forward, so we improve the product as we go along, getting feedback. I do want to show you kind of a little more. So this is the phase 1 steps. What you're seeing on the left is just the water product. Again, this is something that's available nationwide in all the coastal regions. In the middle frame, you have the revised water, canopy, and impervious surface. And the right is just the NAPE imagery. But what I really want to kind of point out is, what you're seeing in the raw water surface, I don't know if my mouse is on screen, but you're seeing in the top left, there's a lot of water, and across the bottom, there's a lot of water being mapped, where it's actually a marsh condition. It's not water there. So again, that's why I said there are issues with those initial out-of-the-box AI results. So we take that initial product and we end up with that middle frame where we've cleaned up that water. We've removed water where it doesn't belong. Again, so we do that with the canopy, the water, and the impervious surface to clean up all those layers during phase 1. And then during phase 2 is where we start adding in all those land use categories. So that's what you're seeing now on screen. The darkest brown being your cultivated classes, your tanned color in the middle being like a pasture, the light beige being a natural grassland, bright yellow are bare categories. It's a little tougher to see, but kind of the goldish color are the open space developed. Those are more your managed grasses, your lawns, golf courses, parks, those type of areas. So that's during phase 2, is when all those classes are brought in, modeled in, and edited to create a phase 2 product. Phase 3, this is the wetland phase. We are deep into the wetland phase, or really not deep in the wetland phase. We're kind of getting into the wetland phase now. But we did, for this project area, we did do all the phases for Hancock County over in Mississippi, because it was a small county. We kind of wanted to do a proof of concept for NOAA to show that we can produce this data and we can do it well. So this Hancock County has been through all the processing. So what you're seeing now is just a county level final land cover map. I'll zoom in here. This is kind of north of Bay St. Louis a little bit. So we have a neighborhood up on top. You have all your forest classes. When you start getting into the darker green and all the pinks and the purples and the oranges, those are all your wetland classes that have been now modeled in there. So now you can see where wetlands run in and amongst the neighborhoods right up against the edge. You've got your saltwater versus saltwater and freshwater breaks in there. This is an example moving out more of a rural type situation. Again, you can see the homes alongside the roadway. We do have some pasture classified in there, but this just kind of shows an example. Because we did so much topographic modeling and soils modeling within there, it helped capture some of these palustrin forest, these darker green features. It captured palustrin forest in locations where spectrally in the Landsat data, it really is not showing up. You're not Landsat, NAPE imagery. You're not seeing those wetland features showing up, but we are mapping wetland in those locations. So again, these aren't jurisdictional, but we are mapping potentially wet areas in many of those locations. When we go in, and we've went in and looked at a lot of these where you're not seeing necessarily obvious signs of it. National Wetland Inventory is not showing it. But when you go through Google Earth and you look through the multiple dates of imagery, you'll often see wet signatures. You'll see water present in locations. You'll see species breaks along some of these drainages. So we are feeling fairly confident in what we're mapping for the wetland classes. So again, at the end of the final land cover product, you will have, this level map for the full area. So I guess the next kind of question is where is it and when is it? How are we doing? So for right now, we are getting near completion of phase 2. That's that land use phase. We have just a couple more areas that we are currently modeling and editing. When we finish that up, we'll deliver to NOAA. They'll give us feedback on that. In the meantime, we are actively modeling the wetlands into the locations. So as we finish up a phase 2 area, we go right into modeling those wetlands to prepare, to stage, and get ourselves ready for the editing of that. After that phase 3, again, at that point, it's just final comments. But for this project, we do have a scheduled completion date, looking at the end of May of 2026. We currently are well ahead of schedule on that. So things going well, we'll be well ahead and the product will be available well before then. All products, again, we finish it, we deliver it to NOAA, Office for Coastal Management, and they will be then serving those data up on the NOAA Digital Coast, and there's a link to it. Once it's available, again, some people just wonder, it's not just a pretty map. It is a very pretty map, but it's more than just that. We have found, that land cover and high resolution and high accurate land cover really serves as a foundational data layer for many other uses. Digital Coast, NOAA's Digital Coast, they capture a lot of these use cases through what they call stories from the field. And I've pulled several examples here on the screen. But some of the most obvious ones you can think of, improved flood modeling and risk assessment. So you know what's on the ground, you know where areas are likely to flood. You can then intersect the two and do analysis on that. One thing that's really interesting that the CCAP data, this high resolution data, has been used for, which some of you may be aware of, is the FEMA CRS, or the community rating systems. What that is a community can go through a process to show how they are reducing, or they have reduced risk from flood situations or from flooding situations. Then they can get a lower flood rating via FEMA, which lowers flood rates across the board for the whole community, thus making insurance rates cheaper for everyone who's affected in that area. One of the data layers that's used within it is like, what area, how much green space do you have? How much impervious surface is there? How much of that green space is protected or not protected? Having a high resolution data set like this gets you much better results and has led to significant drops in insurance rates for some communities, because you're now looking at 1 meter roadways and you're getting all the parks captured, as opposed to previously maybe using a 30 meter land cover product, which washes all of that out and shows a lot more impervious surface than maybe there actually is. Other uses, stormwater management, stormwater and water quality, knowing how much impervious surface is there surrounding wetlands or sensitive areas. They use this in Washington for looking at stream restoration for salmon. These type of data are available. Looking at heat risk, urban forestry, and equity. We recently completed a project, not necessarily using CCAP, but that could be used for this in California, where they mapped urban forest over, or trees, basically urban forestry and other urban locations in California over 2 dates, so they can look at change over time. Obviously, wetland conservation and restoration. Just knowing where you have wetlands is very valuable, so you can focus your priorities if you're going to conserve or restore some of those. And also, this data was used in Alaska, actually, for broadband infrastructure access. So I wasn't involved with that product, but again, these are all varied uses for how this data can be used. At this point, I'm not sure, did Dave Stein, was he able to hop online?
Yes, I am here.
Yes. Okay.
Can you hear me?
Yes.
Sorry
So
about that.
Dave Stein is online again. So I'm kind of wrapping up mine as to how we produce it, what we're doing it, why we can use it. But now I want to kind of turn over to Dave very briefly to say, well, if you're interested in doing it yourself or adding on to this data, what are some of the options? So I'll turn it over to Dave now. I don't know if you can see the slide, Dave, but I've got.
Yeah, I can see it.
All right. So
Yeah,
you're up.
appreciate it, John. Hey, everybody, I'm Dave Stein, and I work at Dewberry with Nathaniel and John. And John and I used to work together at the NOAA Office for Coastal Management, where we built these land cover products for customers around the country. And I happen to be the COTAR, the contracting officer representative on the Coastal Geospatial Services contract. And if anybody's interested in pursuing some of these products anywhere in Alabama, it's a really good vehicle to use because it's open to any coastal state that has a geospatial service need. It's a 5-year IDIQ, or indefinite delivery, indefinite quantity type of contract. We're in our 5th year now, but it's been recompeted, and at NOAA should be announcing new awards for the next 5 years in the next 3 or 4 months. And yeah, I mean, if anybody's interested, just feel free to contact John or myself. And the process is pretty simple. It's just that the agency that has the funding within the state would have to work with somebody at NOAA's Office for Coastal Management to establish an interagency agreement. They would work with you all on a scope of work for the project, and money would be transferred over to NOAA. NOAA would manage the funding, issue a task order. Hopefully it would be to Dewberry, and we would do the work along with NOAA and provide the deliverables to the client, which would be somebody at the state level. So like I said, if anybody's interested in learning more about the contract and how to use it, feel free to contact John or myself.
All right, great. Next, connect with us. Obviously, you guys will have all our contact information. I think Nathaniel was supposed to go to this conference, but I'm not sure he's going to be able to make it to this conference. But we will.
Yeah, we're juggling folks right now. We are a silver sponsor at the GIS of Alabama conference coming up next week. It'll be Eva Reed, who I think she was able to join the call, but she'll be taking my place there. So if you enjoyed this presentation, have other questions, or just want to connect with us, stop by our booth. Tell her how much you love John McComb's presentation, and maybe we'll drop off a business card, tell her your favorite part of it, and we'll send you a special. We'll pick out of those business cards and send you a special gift in recognition of that. Otherwise, there's our contact info. So if you have any questions about CCAP or other services that we're able to provide, would love to talk with you. And that's our presentation for today.
Yeah, really appreciate that guys. We have a little time left if you guys have some time to take questions. If anybody out there has one, we can open the floor now. And if not, that's okay too. They let you know how to get in touch with them if it does come up. I'll mention that the GIS Association of Alabama is also going to be a sponsor of the conference next week, so we'll be there as well. Stop by and say hello to us. And grab some information. We do have our annual meeting scheduled for Wednesday, the 19th at 3:30, and I think in the big room right there. So please come join us for that as well. We'll give another chance to ask any questions if folks have one. All right. Well, again, John, Nathan, Nathaniel, Dave, really appreciate you guys hopping on and talking to us about this. I know it's a product that I use a lot in my work in environmental engineering. So definitely thankful for it. Our next Lunch and Learn we have scheduled for December 5th. We're going to hear about the Geospatial Artificial Intelligence Working Group out of the University of North Alabama. So go to the website, register for that one. If you haven't seen the email yet, we'll love to have you again. If nobody else has anything else, we can go ahead and shut down for the day.
All right. Thanks, Justin.
I
Yep.
appreciate your time.